It's recording. Isn't that cool? Yeah. All of our voices. So I could be like, Sam, sit down. Get back in your seat. No, stop disrupting class. And then I can like email it to your folks or something. No, I wouldn't do that. All right. Let's do number 2. All right, so inputs and outputs. Someone want to start us off with number 2, the first problem? I know I asked you a question and I'm not looking, and I promise I will in a second. Let's see if I can do this. Okay. All right. First one, f of 0. Want to give it a shot? Keith? Yeah. Keith. All right, Keith. So you plug f of 0 in, and what do you get out? 15. Are people in agreement with Keith? Is that okay? 0 is the input. That's the x value. 15 is the output. Great. Keith, calling someone for the next one. F of 4. Peter. Do you want to be called on? Sure. All right, Peter. F of 4. 5. People in agreement with that? You feel all right? Good. 4 is the input. You get 5 out. Just out of curiosity, how can you tell if you're looking at a picture if it's a function or not? You remember, Elizabeth?
Yeah, the vertical line. You draw the vertical line down the center or down the line, and it hits 1 and 1 point.
Right. So if we sort of take this vertical line and we're to bring it through this way or that way, every time it can only intersect at 1 point. If it doesn't, then we don't call it a function. Do you remember what we call it if it's not a function? It hit.
Parabola?
No. There are parabolas that are functions, actually. One of your favorite functions, x squared, right? That's a function. That passes the vertical line test. Certainly, a parabola tipped like this does not. Think you remember? Yeah, nice. That's good. Wow. That was impressive. Not anticipating anyone to remember that. All right, it's a relation. All right. Peter, right? Peter, calling someone for f of what equals 10?
Monty.
2. You feeling good about that? Positive it's not 0.5. So f of 2, when we plug 2 in, we get 10 out. Does that work? I would agree. And Monty, can you call on someone to find f of what equals 5? Oh, what do you know? That was sort of like the second one, right? That's nice. You almost get that one for free. Good. Right? Doesn't that work out nice? Lee, nicely? Thank you. Grammar. See? This is why we need you here. Is that all right? So you want to ask questions? I mean, there are 4 people that knew what they were doing. Does it feel like everyone knew what they were doing, or do you want to ask a question on that? They teach you in teacher school, you're supposed to count till 8 in your head. And, yep. They say that if a student doesn't ask a question after 8 seconds, they're probably not going to, because they're not interested in asking the question. But all too often, we teachers, not us, we teachers, right, grammatically correct, don't give you enough time. We're like, any questions? Good, moving on. So, in 8 seconds, when you think about it, it's actually painfully long.
You have to say this is 52.
Yeah, I was thinking 1,000s. Okay. All right, number 1. Let's have a discussion about that. All right. Number 1. Someone read it. Michelle, can you call someone to read it?
Let F be the temperature in degrees Fahrenheit and T the time of day. Explain why F is a function of T, but T is not usually a function of F.
Okay, so this goes back to what a function is, and we need, I guess, we need 2 answers to this, and it might be from the same person, I'm not sure. But explain why F is a function of T, but T is usually not a function of F. Danny, calling someone.
Wasn't it kind of like the Labra thing? So
if you shaped the lava one way, it would pass that line test. If you were to draw a line the other way, like vertical instead of horizontal, horizontal instead of vertical, it wouldn't pass. That's why it works.
Can you put it in a context, like with the temperature and time idea? Like,
well, T would be like the X
okay.
axis, and F would be the Y axis.
All right, and I'll call it F. Just remember, F really is standing for temperature, capital T, but using two T's might, I don't know, be hard. 1056, I just checked. I was curious too. Well, I didn't want to run out of time. Yeah. So, all right. So, given the fact that little t, the time is probably the x-axis. If we want to think about that as the independent variable, right? Time is independent. Time's going to happen whether we want it or not, right? And what depends on time? In this case, the temperature. So, Evan, talk to me a little bit about what sort of temperatures you get out for any time. If I give you one time, how many temperatures are you going to give me?
One.
Yeah. I mean, could it possibly be 1036 and be two different temperatures outside? Now, in the same place. Like, I mean, I know you can think about being in two different places, but if I'm measuring the temperature, I can't get two different measurements for the one specific time. And that's exactly what we want. That makes it a function. The temperature is a function of time because you get one temperature for every time. All right, Evan, call on someone to tell us a little bit why the other way might not work.
Well, if you go like the other way, you could have one, like it could be for a different time of day, it could be like, sure.
All right, talk to me. Give me an example, like today.
Well, it's like, if it's like 70 degrees at 8 in the morning, it could also be 70 degrees at like 3 in the afternoon.
Great.
So,
That's perfect. All right.
just outputs to the-
Right. So if we had the temperature as the input, right? Like if we put 70 degrees in, we might get two outputs. We might get 7 o'clock and 3 o'clock. Did you say 7 o'clock? No. Yes. 8 o'clock. Sorry. 8 o'clock and 3 o'clock. So that doesn't work. All right. That's a tough concept. Do you want to ask a question on that? Were you? No, I thought. Okay. You're just waving your pencil in enthusiastic revelry for pre-calc. Are people all right with that? If I had to draw a graph of sort of what Evan was talking about, I might draw a graph something like that for like a 24-hour period. Whoops. I don't know what happened there. Would you agree that that might be the temperature? Like it starts off cool, warms up in the middle of the day, ends up cool? Does that look like a reasonable graph? Have you talked about inverses last year in algebra? Inverse functions?
Yeah.
Did you talk about the horizontal line test?
Yeah.
Oh, I'm getting some yeses and some nos, which is always interesting. The horizontal line test, so this says that this passes the vertical line test, right? And this says, look, if time is the independent variable and temperature is the dependent variable, it works. It's a function. The horizontal line test is when we take the line this way, and that tells us whether the inverse, whether if we flip time and temperature, if that's also a function. And this would tell us, no, it doesn't pass the horizontal line test, so that actually goes back
The
to the
inverse is like not the fraction, but you like do that like thing.
So we're not quite there yet, but if we were to say f is a function of t, we might say something like this. T is the input and the temperature is the output. We would say that the inverse looks like that, which is confusing because sometimes we think that the negative one refers to the reciprocal. And in this case, it's not the reciprocal, it's the inverse. And believe me, we'll get there. You guys are a little ahead of yourselves, but that's because you're so smart. Way to be. All right. Is that okay? Questions, comments, concerns? For real, or you just don't want to say anything because it's the first day? You would say something if you wanted to, right? Travis, if you wanted to say something, you'd say it, right? Okay. So you're going to give your, now I'm going to do the teacher thing where I have lots of things to give you, and I will do that. Let me first, I'm getting there.